The earth beneath us is home to immeasurable treasures. Billions of tiny creatures teem in just a handful of healthy soil.
We get an energy that didn't exist before, just from living organisms.
Living soil is the foundation of our life.
A much larger part of biodiversity lives below the soil.
And yet, most fields are silent as intense agriculture and extreme weather put pressure on the soil.
Und konntest sehen, wirklich jede Erbse kaputt.
Can anything be done?
It's so bad that we have to repair broken soil.
I own a farm. It's been in our family since the 1600s, and now it's my turn. If I treat the soil the way it's been treated everywhere, my grandson won't be able to live from it.
Mark Dümischen Farms, south of Berlin near the village of Flaming.
Here you can really see that the soil is degraded, and that's a shame. The fertility is degraded. You can't even stick your finger in it. You can barely break it up. As you can see, there's still moisture down here, but the soil is a mess. It can no longer regenerate itself. We've realized that we can't go on like this. The soils have reached their limit. You see dust storms and sandstorms over and over, not just once, but 5 times a year. They used to happen once every 10 years. Now it's 5 times a year.
Clearing huge fields to make life easier for combines is just one reason soil in northeastern Germany has degraded. The consequences are obvious. Fields dry out faster and also blow away more easily. Sandy soils, here in yellow, cover the region. They are the most infertile soils and also receive the least precipitation. According to the Drought Monitor, the areas to the east of the river Elbe are especially vulnerable. The largest desert in Germany lies in Brandenburg, south of Germany's capital, and covers 5 square kilometers. Tanks crawled over the sand on this training ground for decades. Only specially adapted plants, dry grasses, and lichens have survived in the Liberos Desert. Agriculture is unthinkable.
Brandenburg has been hit hard, and eastern Germany generally, because we're in the more continental part of the country, a long way from the sea. In Brandenburg, we often have these sandy soils, which are not very good at storing water. And then there is also climate change, with more heat and a decrease in precipitation, or possibly longer phases without it in summer. That ultimately makes Brandenburg especially vulnerable to climate change.
Farmers are alarmed. What will grow in the future? How much will they have to adapt? Some are already experimenting with arable Asian crops. Chickpeas, for example, which experts predict have a future on native European soils. They're seen as a first-class soil conditioner. But will they work on the continent? At Gut Friedersdorf, in the Märkisch Oderland region between Berlin and Poland, organic farmer Bernhard von der Marwitz cultivates barren sandy soils. His yields of native pulses, such as peas and broad beans, are waning.
The soil has very high water permeability. It dries out very quickly. Chickpeas need drier terrain. This is generally good for chickpeas.
He's sourced 40 bags of seeds from the south of France, but there are no guarantees they will sprout.
We are experimenting and trying out different varieties to figure out which is the best suited to our location.
Planting time. The seed drill usually plants maize, but today chickpeas. The experiment begins. It's the end of April, and the weather conditions are favorable. Scientists and a regional marketing organization are also interested in whether and how the farmers' experiment will succeed. Expectations are high. Experience is desperately needed. How deep should the seeds be sowed? Isabella Krause works at Regionalwert AG, a local food production agency. She wants the garbanzo bean to become a permanent resident in Brandenburg.
The complicated thing about agriculture is that you can never copy-paste. I can't look at the conditions in India, Australia or Canada and then do the same here. Conditions vary locally, even within a small radius. You have to do things differently. Of course we can look at how things are done over there, but then we always have to rethink everything.
11 hectares will be planted today. That ideally would translate to 11 tons of the protein power crop. That's the plan, but only time will tell. The field has been divided into several areas to monitor how the chickpea grows under different conditions.
Chickpeas are perfect for the soil because it's a legume that can accumulate nitrogen. And it's perfect for humans because it's rich in protein, it's rich in fiber, it's extremely versatile, from chickpea flour to chickpea pasta and crisps. It's used everywhere in the kitchen. It's not only healthy, but also extremely tasty. And let's not forget, humus and falafel.
The seed should take 2 to 3 weeks to sprout. Its new home, the sandy soil of Brandenburg, eastern Germany, created by the last ice age around 15,000 years ago. Layers of river sand, gravel, and a few clay particles are typical of this region. But the soil is more than just layers of sand. This 3D scan of a soil sample shows its typical texture, a branched system of roots, passages, and cavities. This abundance of space is what makes it so valuable as a water reservoir. A single cubic meter of soil can hold up to 300 liters of water. At its best, it's a large sponge.
The soil is basically the most important space for water interaction. Precipitation falls on the soil, and the soil decides how much of it actually infiltrates and how much runs off on the surface. Of course, we humans influence what the soil ultimately does with the water through our land use and soil management.
An organic farm in Rupenerland, north of Berlin. Lena and Philipp Adler have been thinking a lot about the soil for the past 5 years. Their harvest is eaten in restaurants by self-pickers and members. But the beginning was not easy amidst the 2019 drought.
Completely insane.
It was really like a desert here. Once we turned it over, it was all open and bare, and I think it had even been tilled once over a large area.
Yes, it looked bad.
And then the summer with the drought, and it dried out 30, 40 centimeters down.
Philipp and Lena hope to counter the poor sandy soils by diversifying above and below ground. Over 120 colorful varieties of organic vegetables are cultivated on 3 hectares of land.
The soil loves diversity, to put it in a nutshell, because roots act differently and need different spaces, i.e. they're very widely distributed. We don't yet know all the connections. We don't yet know what exactly happens in the soil, especially with the microbiome, and what the interactions are. But new studies worldwide show that diversity can actually make the soil more resilient than monocultures can.
Growing different kinds of vegetables is more work. Each has its own specific needs. The rare and heirloom varieties grown by the pair are most interesting to customers. And the soil likes them too.
You can even do a bit of soil building with different crops. Cabbage is a heavy feeder. It takes away a lot. Beans bring in a lot, and so on. If you establish a sensible crop rotation, you can also improve the soil, even in terms of crop management. And that's actually the goal, that you build up the soil as part of the cultivation itself, instead of depleting it all.
This is what their fields look like in the off-season. Short-living plants, known as catch crops, are planted in the off-season to boost diversity and support the soil.
We usually sow vetch in winter. It grows a little in the first year and continues to grow the next year, so the soil is never bare. No nutrients are washed out, soil life can continue, water is retained better, and the following year, we already basically have the first fertilizer step in place.
Legumes, such as vetch, peas, and beans, are part of the cure. They draw nitrogen from the air, and by working with special bacteria, store it in small nodules at the roots.
Here you can see it. Lots of bacteria nodules here.
This provides natural fertilizer for next season's vegetables. The catch crop is mown and covered if it doesn't freeze off in winter. The soil does the rest, making space and food for the vegetables.
With a very diverse soil life, with a greater diversity, we can better react to sudden events or shocks, because there are always certain specialized organisms that come into play.
Marc Dumischen has already harvested his grain. Now he wants to diversify his fields.
This is the main seed, the core seed for the front box. It contains oats, barley, peas, vetch, sunflowers, and ceradella.
Finer seeds, such as clover and a bee pasture mixture, are also included. Greenery and humus are to be built up in the soil as quickly as possible.
That's going in today, and the fine seed will take about 2 days. The coarse seed, that takes a week. But the fine seed starts sprouting in 2 days and starts forming its first hair roots and its first seedlings. And then it starts again with the covered area. It's basically just a soil conditioner because we don't harvest it and we leave it until next spring.
The big rethink began 20 years ago.
We used to plough after the harvest to break the rubble and turn the soil over. Stones in the soil surfaced. My father always said, look, we're not getting anywhere, we're harvesting so little. Not in terms of quintals, but we're harvesting too little for what we're actually putting in. We said, okay, we'll stop doing it. We'll do something different. We'll just stop ploughing.
Dumischen has tried a lot of things, researched, attended soil management courses. He even traveled to Brazil to see how crops are grown there. He learned about no-till farming, where crops are sown directly after the harvest. No plowing. The seed drill slits the soil only slightly, protecting soil life.
We know from other countries that have been doing this for decades that it's the only way. There is no other way. And not because I say so, but because all other ways have been tried for centuries, or for at least about 200 years. And all of them have led to carbon depletion and soil fertility degradation.
He's now a fixture in the no-till scene. He travels to conferences, gives talks, and offers guided tours of his farm. He shares with other farmers via social media, and is recognized for his pioneering work.
Of course, I'm proud when someone says, okay, he's not talking garbage. What he said is actually true. It's great if they avoid the same mistakes we made 10 or 15 years ago. We already did everything wrong. Others don't need to repeat it. Things can move faster. And that's probably why we're seeing such an increase in the number of people who are now showing up and starting this everywhere, even if it's just experiments.
Many have already switched from plowing to more gentle cultivation methods, but only a few do direct sowing. The method has no lobby, because it saves both diesel and fertilizer.
This is a pea. Here's a vetch, a black vetch, a white pea, another pea. It's full of them. Now it's quiet here, and the animal world, the insect world, the mushroom world can start to live here and process it all, rework the soil. The straw on top will be eaten away by next year. It will look like it does now, and then it will all fall down again. The plants in between die. Some do, some don't. Some freeze, some don't freeze. Then leaves fall down and form the next nutrient carpet for the diversity that we maintain here.
His soil used to only have 1% humus. Now it's 2%, which is still very low. Creating change is a generational task.
The soil is now giving back some of what we've been putting into it for years, and we're realizing that now, because in dry years we still farm, and even in very dry years we still farm. Nothing is gone or broken.
But who are the many little helpers for soil fertility, and what do they need to survive? Water is clearly critical for all soil dwellers to thrive. But the food supply is also crucial. Both are in short supply on many soils in Brandenburg. Soil zoologist Nicole Scheunemann is on a sand dune at the edge of a military training area. She knows that the desert is also alive. She has already found tiny survivors here, such as springtails, albeit sparsely populated, she says, similar to conventionally cultivated farmland.
A field's conditions are relatively similar to a desert. Not much input of organic material because any produce grown is usually harvested and isn't returned to the soil. This means that resources, materials are extracted, but not much goes in. If only mineral fertilizers are used, there is no organic material for animals to break down.
But this meadow is teeming with diversity. The top few centimeters are full of life. It's easy to see in the darker humus in the soil sample. Lots of roots and organic matter. Tricks have to be used to lure small insects out of the soil. Light and warmth are used to entice the soil dwellers to move downward through the funnel. The first to crawl around are horn mites. 20,000 live in 1 square meter of field. They effectively decompose plant residues and animal feces. The small springtails sometimes even appear en masse, but they are shy and flee from light.
They like to live hidden in the dark. Light is dangerous for such small animals, which don't have much to counter the light. If they can perceive dark and light, it's so they can withdraw from the light.
Threadworms, also known as nematodes, are by far the most numerous soil dwellers. 4 out of 5 living creatures belong to this group of small, wriggling worms. They decompose and transport plant residues in the soil.
We have bacteria eaters, we have fungus eaters, we have algae eaters in the soil. We have the bad guys that pierce and suck out the plant roots. All in all, these nematodes accelerate the cycle of decomposition. The ones that eat the bacteria and fungi are particularly busy because they ensure more turnover among the bacteria and fungi. They also work faster.
Soils with high fertility are full of fungi and bacteria. They decompose particles into the smallest structures and make nutrients available to plants. The hotspots are mainly in the root area, where the finest fungal filaments connect with root ends. There is food for everyone and plenty of plant sugars. Biologists are only just beginning to decipher these previously unknown interactions. Today is an important day for Brandenburg's chickpea commissioner. A rendezvous in a field near Trebin, southwest of Berlin. High-ranking politicians are part of the meeting. The stakes seem higher than at first sight. The protein power crop, which is said to be both climate-resistant and soil-friendly, is of interest to the Federal Minister of Agriculture, as well as a high-ranking ministry official and her entourage. Isabella Krause takes the opportunity to promote her project.
The more I talk to farmers in the region, the more I also sense their despair. They have questions. What will we still be able to grow in the future? Another very, very important point is cooperation. We need an association of farmers in the region who say, we believe in chickpeas, we will further develop them together.
The canteen chef at the Trebin Agricultural Cooperative is also a fan of chickpeas. He's making falafel from last year's harvest. But it will only be served later, after the minister has toured the field. Meanwhile, the two farmers discuss their experiences with the legume. The farm is known for its willingness to experiment.
The knowledge gained here will one day benefit all of German agriculture. I come from Baden-Württemberg, where we have completely different conditions. Much smaller farms, a different soil situation. And guess what the farmers there say to me? We're experimenting. We're looking at chickpeas. We're looking at what plants we can add to our range.
It's time for the tastier part of the event, where the minister gets to try Brandenburg chickpeas. Next comes the less pleasurable part, the realities of farming. The seed failed to sprout in many areas. Farmer Jana Gebert blames the poor soil quality.
They're having an incredibly hard time here. If we look to the right, left, or front and back, the differences are clear.
It's really interesting. When I look at it, there's sand everywhere. It doesn't look so different at first. When you walk on here, you realize it's also quite dry. It's like a beach.
That's right. What makes us different from the desert? We have a bit more rainfall. Apart from that, we have sandy soil here.
100 kilometers to the east in Friedersdorf, Bernhard von der Marwitz is inspecting his chickpeas. The Arenca variety has sprouted really well. Strong growth, dense rows. It's looking good. But it's the only variety, and he's only sown 1 hectare, a narrow strip. The rest is a total failure. 10 hectares of chickpeas sown in vain. What's growing here in light green is a substitute, sunflowers.
Row after row. You could dig up the row and you could really see how every plant was broken. I went out every day and looked, dug and dug, and realized, okay, they're starting to germinate, and was like, okay, maybe it'll work. Then you're euphoric. Then I wasn't here for a weekend. When I came back, I thought they should have been here by now. The situation in the ground was the same. They were rotting. It smelled of mold. They looked like they'd been eaten, moldy.
Why? Is it the soil, or is it the type of chickpea? The Leibniz Institute for Agricultural Landscape Research analyzed soil samples from Friedersdorf. Biologist Elisabeth Bellinghoff has a suspicion.
These tents are here because we found fly larvae on the seeds from the farms, and we want to catch them in these tents so that we can identify them. You can see it quite clearly here. Here we caught them. They could be one of the reasons why the chickpeas have grown so poorly. They probably belong to the Delia species, a pest that feeds on chickpea seeds.
This begs the question, why did the fly larva only destroy one variety, but ignored the other one?
That's still an exciting, unanswered question. For now, it's an observation, and it could be that it has a slightly thicker shell, or also colorings and flavorings in the shell that deterred the fly, but we don't know yet.
Chickpeas have been under the microscope here in Müncheberg, also in Brandenburg, for 3 years now. One thing is clear. Not all chickpeas are the same. Mossab Halwani is leading the experiment. He became familiar with the crop back home in Syria.
This variety, compared to the others,
Wow, what a difference. You can also see that it's going to be darker and it's more or less a classic chickpea.
exactly, the classic light-colored one.
They're hopeful the crop will succeed here.
That's why at the very beginning, for the first 2 years, I monitored the weather. The weather data. What does it look like? When is the best time to sow? Is it right for chickpeas? You could compare the climate back then with that of my hometown, Aleppo. It was almost the same. Even in Aleppo, we don't have rainfall of more than 350 or 400 if all goes well. The situation today in Brandenburg is similar.
With temperatures reaching new records every year, growing seasons are shifting. Chickpeas are clearly one way to adapt to the new conditions.
First of all, it's getting warmer. That's the main point. And that leads to more evaporation. That means we have less water in the system, even if it rains more in the future. Secondly, there's a shift in rainfall, with more in the winter months, when we don't need it. Then there's the fact that the weather phenomena are obviously changing in such a way that once the weather conditions are stable, they last longer.
Might trees also help protect farmland? In Prignitz, northwest of Berlin, at least one farmer is convinced trees are the answer for the tricky soil.
You could take some for a sandpit for the grandkids.
He started planting rows of poplars on his farmland 5 years ago. And his soil has already begun to change. A process that usually takes decades.
You can see that the rooting of the soil is beautiful here. We have weeds growing here. No problem. I'll dig a bit deeper. And here we have the entire root system. We have the leaves that fall down, we have the shade. In other words, the soil life will find completely different climatic conditions here and develop much more intensively because there is no tillage.
Rainer Guhl was able to convince the owners of his land to allow him to plant forests on the farmland. This is unusual because every hectare is valuable to the farmer. But that's exactly why he says he needs the trees. They help him with his work, 365 days a year.
There are over 17,000 poplars here. Of course, it's much cooler here than out there. We have this evaporative cooling here. The trees are alive. We are creating green corridors. And the nice thing is that as a conventional farm, I now have an organic tree strip here. It warms my heart. There's no pesticides, no fertilizer. We use the trees. The animals that hide in these strips is surprising. This has nothing to do with the agriculture in between, but it's fascinating to see what happens here. That the pheasants fly from right to left, that we have partridges and hares. And this is a decelerated area that does wonderful things for the flora and fauna.
Skeptics claim the trees would steal the nutrients his wheat needed. But his experience has been exactly the opposite. The grain grows just as well right next to the trees as it does in the field. What's more, the light soil is held together better, which helps prevent erosion.
What do we see? Yesterday, for example, the dust didn't blow into the village. The rows of trees filter it out. These are effects that you only notice if you work with the system every day.
2 hectares of trees on 140 hectares of farmland.
We have evaporative cooling. The trees provide shade and break the wind. And the rows of trees just don't let the moisture escape. That's something no machine can do.
Rainer Guhl thinks trees are better than any sprinkler system. Farmers in Fleming have also started planting trees in their fields. Young poplars grow above one of Mark Dumischen's fields. Cereals will soon begin to sprout between the trees. But how is soil life supposed to restart after a field has been intensively farmed and depleted for years? Mark has started making his own compost to regenerate the soil. Plant residues such as straw, grass leaves, wood, and clay become ready-made humus within 6 weeks.
It smells like the forest floor. That's how it should be, and that's a very pleasant smell.
Countless soil creatures help again to break down the material. Their excretions form a kind of cement for stable soil structures. This is needed to better store water and nutrients.
This is different from the compost that is generally produced and can be bought in hardware stores or elsewhere. This compost is a controlled compost, which means that the composting, the rotting, is controlled by adding water every day and turning it slowly to keep it cool.
The finished compost is spread on the fields like fertilizer. But is it worth the effort?
If you dig up the rainforest soil, you get 5 centimeters of organic matter. Then there's a few centimeters of red soil, and that results in growth that we don't find in Europe. But nobody throws fertilizer there, nobody plows it. I wouldn't say that we need rainforest here. We still have to harvest grain, but we want to replicate that. We have to replicate this system.
Dumischen's family has been farming here for over 400 years. His ancestors always struggled to bring in a good harvest, and now climate change is making things even harder. But Dumischen wants to eventually pass the farm on to his son. The compost is a first step, but it's not enough for all the land. He has found a way to multiply the soil helpers. The method is called compost tea. He leaves the compost in a kind of tea bag and warm water for 1 to 2 days. He also adds a cup of honey and rock flour. The unusual concoction smells like malt beer and herbal tea. The microbes can't seem to get enough.
You can't really see what it does, but I know it's good because the plants are all very, very healthy. I don't need any more plant protection products in the form of fungicides. It's all done with the compost tea and it works very well.
It has not yet been proven whether compost tea promotes humus formation. But Mark Dumischen is convinced. For him, direct sowing, catch crops and compost tea go hand in hand. He applies his infusion to his fields up to 3 times a season. He's spraying it on a maize field today. He only sprays at dusk or at night to protect light-shy bacteria from being destroyed by the sun.
A real energy is created that we didn't have before, all just from living organisms. There are entire cultures that are now starting to work and take effect that weren't there before. And the plant really makes use of it and continues to do what it does, even in bad conditions. In other words, it does what it otherwise wouldn't be able to do because of heavy rainfall or a drought or extreme sunshine. The plant keeps its head down and works to save itself. And now we can assume that the plant will get back to work right after it gets hit with the plant tea.
Marc Dumachen used to have to spray expensive chemicals. Thanks to his new method, he can now almost do without them. Climate change isn't just making the weather warmer, but also less predictable. Healthy soil can act as a buffer. A heavy summer downpour falls on Philip and Lena Adler's vegetable plot. The soil absorbs the water. After a short time, it has all seeped away. Philip also uses bacteria to help the soil.
This is a fermentation. It rejuvenates the soil. We think our soil is already quite well revitalized, but we still want to give it a little something along the way. At a good temperature, this takes 10 days or a week. You can measure the pH value. I smell it. If it smells good, we use it. I just hope that it's full of good bacteria, which I can now add to the soil that I'm stressing at the moment.
The fermentation is made from plant residues, for example, kitchen waste. But unlike compost, it is fermented by lactic acid bacteria in the absence of air. This produces a sour-smelling liquid full of microorganisms and nutrients. Philip regularly spreads the concoction on his fields.
Other farmers laugh that I do it by hand, at a snail's pace. They just use their tractors. They laugh at such home remedies anyway.
The importance of good gut bacteria for human health is undisputed. Similarly, the realization that soil is more than just something that holds plants is gaining ground. It's a system full of life. Organic farming leverages this knowledge. In the absence of chemicals, gardeners and farmers look for natural allies, as well as good old-fashioned trickery.
Firstly, the plastic prevents the weeds from growing. They start to germinate, and then they don't get any light, and then they die. That saves us a lot of work. And it gives the pumpkins and zucchini a lot of warmth. Water also passes through the plastic. This means that all the soil organisms feel totally at home underneath. No birds can get at them, they aren't eaten and have constant moisture and can also feed on the weeds and the compost that we've brought in here.
Advanced cultivation techniques allow the Adlers to grow a lot on a small farm. And the soil is also improving noticeably.
Now we're in our 5th year. I'd say we're starting to really notice that the soil structure is creating results. It's always a long process. And in 10 years, we'll hopefully notice it even more.
Why don't more farms follow suit? The pair work from dawn to dusk during growing seasons. Overtime, physical labor, and ideology are all a part of it. Lena and Philip call their farming method organic intensive. Why not regenerative, a currently popular term?
Regenerative would be an understatement for what we do. We are working to improve the soil sustainably.
I think this term was introduced to set a standard that should actually be normal, to bring it back. Because regenerative actually means that you make something that is broken whole again. It's bad enough that we have to start making ruined soils whole again.
The die-hard organics would say that they've always been doing it. I think it's good that conventional farmers are now also thinking about how they can improve their fields.
Harvest time in Friedersdorf. The chickpeas have ripened well, yet only 1 hectare has really sprouted, a bitter setback. All hope now lies in the remaining strip of land planted with the Arenca variety, the brown chickpea.
I would say it's not looking too bad. We may well reach the ton per hectare mark. That's my first guess.
Of course, it's really emotional. This whole process that we've gone through together somehow nearing its end. And it's getting really exciting now. We can't celebrate yet. We still need to harvest and then look at the results. And then clean the product. The chickpeas aren't on the plate just yet. But seeing this process and hearing the rustle makes me very happy.
The large combine doesn't even need half an hour to bring in the entire chickpea crop. Bernhard isn't thinking about giving up, despite the setbacks. Something will make it onto the plate after all. A curry is on the menu at the farm's restaurant. The first time ever with Arenca chickpeas. The farmer, the combine driver, and an agricultural economist can't wait to taste it.
It's super tasty. I think it's really nice when chickpeas add texture to food. It's not just porridge.
A slightly nutty flavour. Together with the vegetables, let's say firm, a nice combination. Very tasty.
I don't mean to get ahead of myself, but maybe this is the start of the Brandenburg chickpea, which will be red and not beige.
New produce is conquering Brandenburg. Farmers are restructuring their fields and the landscape is also changing. A movement is underway. The living soil is its beating heart.